Welcome to a video on Phaser, the HTML5 video game framework. So in this video, we're going to build on the concepts I covered in the last video on this basic platformer series. So this is part 2. And of course, you can always find the source code at this bit.ly right here, bit.ly/PhaserFriday15_02. Will be all the source code in a zip file that I'm going to go over in this video. So we're looking at the index.html file here, and nothing has really changed from the previous video. We're still doing the same things. We're including Phaser, we're including our game script, and of course we have an element that has the ID set to Phaser, which will be the element that the game will be created within. Let's move over to the game.js. So from the last video, it hasn't changed much, but I've noted in each section here, and each function of the Phaser game object, where I've made the changes and what's new in this video. So primarily we're still creating a game object as be our primary object that we load everything and run everything from. That's all the same. It's still 500 by 500 pixels, width and height. We're still using Phaser Auto, and of course the parent element of the game is still an element with the ID of Phaser. And of course we have our three main functions: our preload function, our create function, and our update function. So in preload, the changes for this part 2 are these two function calls right here. We're loading a tile map, and we're loading an image that will be the basis of the visual part of that tile map. So for the tile map, we're actually loading a JSON file, map.json, and it follows the tiled JSON format, which is a special format that Phaser knows, which uses a program called tiled. Now unfortunately, I won't be going over how to use tiled in this video, but the file I've created with it, map.json, used tiled to create the JSON file, which I'll be using in this example. And of course, it uses level.png. So let's look at those for a second. The map.json file, created by the tiled program, basically creates a height and a width within a JSON object that has layers. And the layers describe where the different pieces of the tile map go. So you notice here we have 1, 1, 4, 4, 4, 4, etc. So that's where, using this giant array, the tiles will be shown on the screen. And of course they created with level. And this is level.png. You notice it's 300 by 64. So it's 5 tiles, each 64 pixels wide. And it looks a little weird looking at it this way, but we're actually looking at one that's solid black, one that has a left edge, one that has a right edge, one that has a down edge, and one that has a top edge of white for each of them. So moving back to our game.js file, we see, okay, so we're loading a tile map, and we're loading an image that'll be the basis of that tile map. We're also creating two new variables for this part 2. We have a map variable, and we have a layer variable. And then within our create function, we're using those in this section right here. So the first thing we're doing is adding a tile map, similar to how we added a sprite right here using game.add.sprite. We can add a tile map the same way, game.add.tilemap. And then we supply the tile map cache key. Remember up here, map is the name as the cache key for the tile map that's associated with this asset right here, the map.json. So okay, create a tile map, use that resource, the JSON file, to create the tile map. Now, once you've done that, and it's saved in this reference variable, from that reference variable, we're going to add a tileset image. We're going to base this on level. So level, of course, is the image cache key of the asset of level.png. So we're saying, okay, we've created a map and we've loaded all of the information for that map. Now create the visual component of that map by adding a tileset image that matches this cache key of the image I'm supplying. Go look for that image and create the tile map using that image. And then the third thing we're doing is setting collision. Now, you don't necessarily have to have collisions every time you use a tile map, but in this case, because we want the player to collide with the tile map, we need to set a collision. So we're setting a collision between the first cell with number 1 through cell with number 5. Or we're setting the first 5 here within the map. And of course, the next thing we're doing here is we're saying, okay, well, we've set collision, go ahead and create a layer based on the information that was in map.json. So the name of the first, so within the layers array, look for something called tile layer 1, which is a default name created by tiled. So okay, create a layer based on tile layer 1, then layer resize the entire world to match the size of that layer. So we started where our whole world was 500 pixels by 500 pixels. Now we're telling the layer, we're giving it permission basically to say, okay, resize this entire game world to match your size. However big you are, make the world that size now. Which allows us to expand the world tremendously by loading a large in size tile map. And so we can create gigantic levels like you would see in side scrollers or top-down shooters or whatever, all based on, instead of making the game world that size initially, we'll make it a smaller size, our initial scene, if you will, our initial view, and then we use the layer to resize the world to a gigantic size if we want it that way. And of course, from that end of this part 2 tile map loading, we're creating a game sprite, and I've changed the positions just slightly here to match so that the player does not start inside the tile map and starts outside of it. And of course, since the tiles are 64 by 64, I set it to 7 tiles in, 13 tiles down. And of course, we're enabling the physics on the player. And once we've done that, once the player has a body, a physics body, we can set gravity, so we're setting gravity. And this is the final new thing right here, that we're telling the game camera to follow the player. Now the reason for this is if we don't set this right here, if we're not the camera isn't following anything, the camera will stay at that initial 500 by 500 pixels we set at the very beginning. But because the world is so much bigger, because we've added a layer here within the tile map, and we've resized the world, we want the camera to go with the player. So when the player moves out of that initial 500 by 500, the game camera will follow the player. So I forgot to mention, I skipped over right here, that I actually turned the collide world bounds boolean off in the above here, that I've actually commented it out. The reason for this is that we don't actually need it anymore. I'm leaving it in the code so I can explain it right here, but we don't need that anymore because we now have a tile map that wraps all the way around. As you'll see when I run the example, that locks the player in so they can't get out of the tile map anyway, and the tile map is inside the game world. So there's no reason to collide with the world bounds if the player's never going to reach that. So the update within the function update is this new player layer collision. Now, if you remember, I mentioned in the first video that we enable the physics system and set Phaser Physics Arcade. We're using the arcade physics system within Phaser. So whenever we want a sprite or a group of sprites to collide with a layer, we need to put that somewhere in a function call. So this is game.physics.arcade, because we're using the arcade physics system from the game object. And we're using its collide functionality. And we're saying, okay, collide the player with a layer. So whenever the player is touching the layer, it won't pass through. They'll collide. By default, Phaser will stop anything from continuing to intersect each other. So once the player hits a layer, like hits the ground or hits a wall or something, they'll stop. They won't keep going into it. They won't pass through it. Game.physics.arcade.collide, the collide functionality of the arcade physics system, also returns a Boolean value each time, either true or false, if, when an update happens, the player is colliding with the layer, or the layer is colliding with the player. Of course, when you check one, you check the other at the same time. So that's what we want to happen. So we say, okay, for this game, we don't want the player moving into the walls. And we don't want the player moving into the floor or the ceiling anywhere. We want to stop that from happening. And then the rest of the code is the normal velocity checking and keyboard checking I went over in the last video. We're checking frames, we're checking if buttons are pressed down, and we're changing accordingly within our update function. So let's actually look at how this looks like in practice. So I've pulled it up here in Chrome. I'll refresh so we can see. We see our player moves down. If I press right on the keyboard, then moves right. And notice our world is a great deal bigger. So we can keep moving right until we run into a wall. And so I can jump into the wall, and I won't pass through. And I can run into the wall, and I also won't pass through. And I can just keep pressing right on the keyboard, and I will never pass through the wall. Notice I'm also not passing through the floor as well. This is all that collision function happening. So by default, Phaser stops things from continuing to intersect. They intersect and they're stopped. So the player doesn't pass through the wall, doesn't pass through the floor. And notice our world is tremendously bigger too. Our game world now is not limited to the 500 by 500 pixels. It's limited to the size of the layer, which is a great deal bigger. And the camera is following the player as well. So as we move through the layer, as we continue to move, and we're not stopped by any tiles within the layer, we can move through a much bigger game world by using a tile map, creating a layer, and then doing collision from the player against the tile map, against the layer within the tile map, that is. And of course, you can always try this on your own by downloading the source code and playing with it, which I suggest you do. Definitely get to know how Phaser does things and change some values. Maybe change the gravity or change horizontal movement or vertical movement. Just play with the values of it and see which ones you like and which ones you think you'll need should you create a game based on the same idea. Thanks for watching.